Hello, hello everyone. This video is going to cover evaluate combinations of functions and composite functions. And so let's go ahead and get started. So if we have two functions, find the following: f of x is equal to 3x and f of x is equal to 3x minus 7 and g of x is equal to 4 minus x. If we want to add, subtract, multiply, or divide, we can rewrite these as they're defined. So f plus g of x is equal to f of x plus g of x. And so our next step would be to substitute f of x and g of x. So f of x is 3x minus 7 and g of x is 4 minus x. Then we're going to simplify. So 3x minus x is 2x. Negative 7 plus 4 is negative 3. If we want to subtract, we can rewrite it as well as f of x minus g of x. Substitute our functions. So f of x is 3x minus 7 minus g of x is 4 minus x. Notice here I put parentheses so that this subtraction can be distributed into the whole g of x. So we end up with 3x minus 7. Distribute the negative, so negative 4. Negative is positive x. Combine your like terms. So 3x plus x is 4x. Negative 7 minus 4, negative 11. For multiplication, we have f of x times g of x. So we have 3x minus 7 times 4 minus x. We're going to go ahead and multiply. So 3x times 4 is 12x. 3x times negative x is negative 3x squared. Negative 7 times 4 is negative 28. Negative 7 times negative x is positive 7x. So we end up with negative 3x squared plus 19x minus 28 as our solution. For division, we have f of x divided by g of x. And so if we substitute f of x, we get 3x minus 7, and g of x is 4 minus x. The other thing we want to do is find the domain. So notice here we have a fraction. So we can set the denominator equal to 0 and solve for x. So x is equal to 4, this f for 4. So we can write it as interval notation, negative infinity all the way to 4, union 4 to infinity. Let's try another example. So for f plus g, we can rewrite this as f of x plus g of x. Substitute our functions. So f of x is x squared. G of x is 2x minus 5. Combine any like terms. We don't have any. So that's going to be our answer. For subtraction, we have f of x minus g of x. So f of x is x squared minus g of x, which is 2x minus 5. Go ahead and distribute the negative. Negative times 2x is negative 2x. Negative is positive 5. We don't have any more like terms, so that would be our solution. Multiplication, we have x squared times 2x minus 5. X squared times 2x is 2x cubed. X squared times negative 5 is negative 5x squared. And that would be our solution. For division, we have f of x divided by g of x. Substitute our functions. F of x is x squared and g of x is 2x minus 5. So the domain, we take our denominator, set it equal to 0, add 5 on both sides, and divide by 2. So the domain is all real numbers except for 5 halves. Interval notation, we can write it as negative infinity to 5 halves, and then 5 halves to infinity. Find the following. We can again add f plus g of x. So substitute our functions. F of x is x squared plus 3, and g of x is the square root of 2 minus x. We can't combine these, so that would be our final answer. For subtraction, f of x again is x squared plus 3 minus the square root of 2 minus x. Distribute the negative, and that would be our answer. Multiplication, f of x is x squared plus 3. G of x is square root of 2 minus x. You can multiply this out, x squared times this, and 3 times this, or you can leave your answer as that. For division, we have x squared plus 3 for f of x, and g of x is square root of 2 minus x. And we can't simplify, so that would be our answer. If we want to find the domain, notice that we have a fraction, but we also have a square root. So for the fraction, we set it equal to 0 and solve for x, so we're going to square both sides. We get 2 minus x is equal to 0, and then solve for x, so x is equal to 2. For the square root, we set the radicand greater than or equal to 0. So here we get that x is less than or equal to 2. So the domain is all real numbers except for 2, or anything less than 2. So your domain is going to be the combination of these two. So anything less than 2 is negative infinity. And then we have our 2. Composite functions. Here we're given two functions, f of x and g of x. So anytime you see this symbol, that means composition. And the way it works is that the function on the left side goes on the outside, and the function on the right side goes on the inside. So we have f of g of x. We're going to substitute g of x in the parentheses. So we now have f of x minus 3. And we evaluate this function. So that means that wherever you see an x in the function, we're going to substitute x minus 3. So here I have an x. So I'm going to go ahead and substitute x minus 3 plus 4 plus 4. Simplify. So we get x minus 3 plus 4 is x plus 1. So that's going to be our composition. If we want to do g composed of f, now g is going to be on the left side and f of x would be on the inside. Substitute f of x is x plus 4. And now we're going to take x plus 4 and plug it in for x in our function g. So I have an x here. I'm going to replace it with x plus 4. And then we have minus 3. And we get x plus 1. These two gave us the same result, but that is just a coincidence. The next one we have g, which is on the outside. Then we have another g, which is on the inside. So we replace g of x with x minus 3. And now wherever I see an x minus 3, I'm going to plug it in for my x. So I get x minus 3, which is going to be x minus 6. Let's try another one. So f composed of g is the same as f of g of x. We're going to replace g of x with x minus 2. And now anywhere we see an x in the function f, we're going to replace it with x minus 2. So x minus 2 here is going to be put into this x. So we end up with x minus 2 squared. Simplify, we're going to multiply it out. So x times x is x squared. X times negative 2 is negative 2x. Then we have a negative 2x and a positive 4. So my answer is x squared minus 4x plus 4. G composed of f of x. F of x is x squared. And now we're going to put x squared in for this x. So we end up with x squared minus 2 as our final answer. G composed of g of x. G of x is x minus 2. We're going to plug it back into itself. And so we get x minus 2, which is x minus 4. The next one, f composed of g, is going to be f of g of x. So we replace g of x with the function, which is x squared. Now we're going to replace x squared into x. And so our answer is going to be the square root of x squared plus 4. For b, we have g of f of x. So we replace f of x with the square root of x plus 4. Now we're going to take this information and plug it into the function g. So we're going to plug in square root of x plus 4 and 2x. And then it's squared. So the square root and the square cancel, become 1. So we end up with x plus 4. Next, we want to find the domain. So the domain of f, which is right here, is going to be, since we have a square root, we set the radicand greater than or equal to 0. So our domain is going to go from -4 to infinity. For g, we have x squared. So that's going to be -infinity to positive infinity. So let's look at the first composition. So the first step here is to find the domain of the composition. So this was our answer. So the domain here, we have to set the radicand greater than or equal to 0. But notice that x is squared. That means that for any negative number, this would still be positive. And so your domain is still going to be -infinity to positive infinity. The second thing is to find the domain of the second function. So the second function here is g. So we're going to find that domain. So the domain of g is -infinity to positive infinity. And then your final domain of the composition is what these two have in common. Well, they have everything in common. So the domain is -infinity to positive infinity. Let's go to letter G. To the letter B, composition of g of f. So again, we find the composition of g composed of f. Since we have a linear equation here, our domain is -infinity to positive infinity. Next, we're going to find the domain of f. Why f? Because f is that second function. So the domain of f here is -4 to infinity. So 1 is -infinity to infinity, and then this one is -4 to infinity. So what do they have in common? They have in common -4 to infinity. So that would be your final domain of the composition. Let's do another one. So here we have f composed of g of x. So g of x is x plus 2. And we're going to substitute x plus 2 in for x. So we end up with 1 divided by x plus 2. For letter B, we're going to reverse that. So f of x is 1 over x. And we're going to take 1 over x, plug it in for x here. And so we get 1 over x plus 2. Now let's find the domains. So the domain of f is everything except for 0. And the domain of g is -infinity to positive infinity. So we look at letter A, we want to find the domain of our answer, which is the composition. And so here we set the denominator equal to 0. So x is equal to -2. That means that your domain cannot include -2. So my domain is from -infinity to -2 union -2 to infinity. Second step is find the domain of the second function. Our second function is g. So the domain of g is -infinity to positive infinity. So what do they have in common? -infinity to -2 union -2 to infinity. That would be our final domain. For the next one, we have the domain of the composition. And for this, it could be any number except for 0. Now, the next thing is consider the domain of f, since f is the inside function. So the domain here is going to be all real numbers except for 0. So finally, the domain of the composition is what they have in common, which is -infinity to 0 and 0 to infinity. The next thing we want to do is find two functions such that their composition will give you this answer. So in other words, here they give us the answer and we're trying to find these two functions. So one of the things you can do is this f of x, since it's the left the outermost left function, that's going to be what is on the outside of the parentheses. The second function is going to be the inside of the parentheses. So in this situation, the second function g of x is going to be 3x plus 9. That's what's inside the parentheses. And then for f of x, it's going to be the outside of the parentheses, which is the square. But then we're going to include a variable, so the variable would be x. If we check our work, then we can check our work here. F of g is going to be f of g of x. So that gives me f of 3x plus 9, which is going to give us our result. Let's try another one. So here, g is the left outmost function. So that's going to be whatever's like on the outside, which in this case is a square root. And then f is going to be the inside since it's the second function. And so if we rewrite this, then g is going to be the square root. And f of x is the inside of the square root, which is 2 minus x. And if we check our work, we can see that that's going to result in this answer. Section 1.9, inverse functions. Are the graphs below functions? So recall we can use a vertical line test to determine if it's a function. If the vertical line touches your graph in one spot, then that's going to be a function. And so both of these are functions. Now we want to ask, do these graphs have inverses? So in order to have an inverse, it has to be a function, which these are, but then we can use a horizontal line test to determine if it has an inverse. So if we draw a horizontal line here, it touches in one location, then that means that this will have an inverse. In this situation, if we draw a line, it touches in two places, that means that it has no inverse. So if a function is a set of ordered pairs, x, y, then the changes produced by f can be undone by reversing the components of all the ordered pairs. So if the ordered pair was x, y, and they're reversed, then we would be having y and x. So find the inverse of f. So the symbol for inverse is this power of -1. And since we want to find the inverse, we're going to switch the x's and y's. So here we have 4, 2. So now we're going to have 2, 4. We have 9, 3. So now we have 3, 9. 36, 6. So now we have 6, 36. So find the inverse. So what we want to do here is we're going to change f of x to y. And then since we're reversing the x and y, we're going to switch them. So instead of y, I'm going to have x. Instead of x, I'm going to have y. Then you want to solve for y. So I'm going to subtract 7 on both sides. So I get x minus 7 equals 2y. I'm going to divide by 2. And then my last step is to switch the y to the symbol f inverse. So my result here is f inverse of x is equal to x minus 7 divided by 2. And so that was the end of this presentation.